Okay. It seems that most of the OpenStacks are tourists. Okay. Let me introduce myself first. I'm a Yongsheng Gong, and is working for 99 Cloud. In a few cycles ago, I'm one of the Neutron core members, and now I'm working as Tech PTL, which is the OpenStack and MV project. And I think tomorrow I have a session to talk about project update of the Tech. If you are interested in it, you can come there to know how the OpenStack community deal with MV use cases. Okay, this is my partner, Johnny. Can you introduce yourself?
Okay. Good morning, everyone. Nice to see you here. I come from China Telecom. I'm Zilan Huan, and I'm the product design and project management of Sdn Hub. If you have any question about this project, you could contact with me by email. Thank you.
Hello. Today we will talk about Sdn Hub Platform, which is used to unify the heterogeneous SDN controllers. This is our today's content. First, we will introduce something about the China Telecom's CTNet 2025. We will talk about the status and the new plan of the CTNet 2025. And after that, we will talk about the Sdn Hub. This is today's main topic. And we will talk about the relationship between Sdn Hub and OpenStack Tricircle. After that, we will show you some sample activity diagrams to show you how we are finishing our jobs. And we will talk about something about future plan to commit our efforts into the community, such as ODL or the Tricircle itself. And if we have time, we will have Q&A.
Okay.
Yeah, please.
Okay. So I will first give some brief introduction into China Telecom's CTNet 2025. And China Telecom is the large-scale and leading company service provider in the world, providing wireline and mobile telecommunication services and other services like cloud computing. Since last year, we started reconstruction our entire network. This new network we call CTNet 2025. Is built on SDN, NF3, and cloud technology. Comparing to a legacy network, it's more intelligent, and it will be data center oriented and horizontally integrated with more flat architecture and unified resource management. And it will be proactive, agile, flexible, and adaptive to all network services. This is the high-level network vision of CTNet 2025. As you could see, the entire network is divided into 3 layers. The bottom layer is infrastructure layer, and the second layer is network function layer, and the upper layer is orchestration layer. In the bottom layer, we will provide the upper layers with generalized virtual resources, including compute, storage, and network. In this infrastructure layer, we will adopt mostly the standardized devices like white box devices and x86-based servers. For some special services that require high performance, we will keep on providing dedicated devices. And for the middle layer, network functions layer, we will provide virtualized network functions here, like VIMS and VPC and VBase and other elements. All these virtualized network functions will be managed by a central cloud management platform, VMFM, and SDN controllers, and other centralized resource management systems. The orchestration layer is service-oriented, and it will provide China Telecom's own service and all third-party applications with the ability to orchestrate network and resources over the entire network. And by the year 2025, China Telecom will achieve the goal of 80% of network function virtualized, and we will support large-scale on-demand services, and we will deploy our new generation operation systems. So as a major cloud service provider in China, China Telecom has deployed many large-scale cloud resources pools in its data centers around China. All this resource pool is managed by a centralized, unified central cloud management platform. And this platform uses OpenStack as an adapter to manage all those heterogeneous compute, storage, and network resources. And it will provide a unified resource view to our customers and manage all these resources by role and region. It also provides API encapsulations for other systems too. All in all, this cloud management platform is a very critical part in our success of the entire CTNet 2025. And comparing to cloud, NFV in China Telecom is still in its early stage, but we are already advancing NFV in many different areas, including VIMS for routing, VEPC for IoT, and vBase for WAN, and other NFV for other areas, such as vCPE for network edge, and vFirewall VLB in data centers. We are constructing the world's largest VIMS network now. Until now, China Telecom has established some NFV-related enterprise-level standards, including standards for NFVI, WIN, NFVO, and some VNFs, including vBase, VIMS, and other VMFs. We've developed our own manual system, which we call eMano, and we also optimized OpenStack for some performance increasement for VNF. And China Telecom is also a platinum member for open source ONNET member. SDN is treated as the footstone of the entire network reconstruction work. We've introduced SDN in many different scenarios, including cloud, internet data center, small and middle-sized enterprises, and residential networks. SDN is becoming the standard building technology of cloud network. So currently, China Telecom mainly deployed overlay SDN, typically VXM-based software overlay, which has a centralized controller and unified managed by a central cloud management platform. We've deployed all these SDN solutions China Telecom deploying is provided by industrial mainstream vendors like Huawei, ZTE, and Nokia. We've deployed overlay SDN in more than 14 provinces, private clouds, covering over 3,000 hosts and more than 400 services. For internet data centers, we've introduced SDN-based intelligent TE systems, both in backbone and big IDCs. And for SME customers, we will provide SDN-based one service to them for them to choose customize their own networks. for residential customers, we've provided SDN-based home gateway. As more and more this SDN solution deployed, we will encounter a big problem in management all these heterogeneous SDN networks. That's why we develop a Sdn Hub. So the most significant problems we are facing now is the unified management problem. As we know, OpenStack doesn't support multiple SDN in one region, and the network model, which defined by Neutron, cannot meet all private clouds needs too. So our cloud management platform has to do a lot of development work on adapting our networks to the vendor SDN solutions, which is a very huge work. And the interoperability is another problem too. As we all know, northbound interfaces, standardization work now is very far behind industrial demands. So vendors tend to provide their own northbound interfaces, which device a lot, and they are different from both syntax and semantics, which means we have to do a lot of adaptive work to their interfaces, and we will cause bad interoperabilities. And another problem we encounter now is interconnection problems. Now, vendor solutions are always isolated from each other, and so as OpenStack regions too. But our tenants have quite a strong requirement on making their networks communication across all these regions and across different SDNs. And they also have the requirement to orchestration their network and services over these multiple regions and multiple SDN controllers. That's why we need to develop a Sdn Hub. So what's Sdn Hub? In short, it's an EVPN-based SDN orchestration platform. It has the ability to orchestrate network service across multiple regions and multiple vendors and multiple SDN controllers. The entire Sdn Hub is composed by 3 components. One is the centralized deployed orchestrator, and the other 2 is the distributed deployed Neutron plugin and Sdn Hub driver. The orchestrator orchestrates network service across different SDN regions and different controllers and different vendors. And while the Neutron plugin provides OpenStack with the ability of multiple SDN support, and Sdn Hub driver is one of the core components. It will provide unified network model and APIs. This network model and API, we will provide it based on our network requirement. And in this layer, we will hide the differences of the vendor controllers and BI. And this driver framework will provide plug-and-play ability for vendor controllers to be plugged in. So besides these systems, we also require underlay vendor SDNs to support EVPN protocol, and they should use EVPN to exchange their own tenant networks so as to provide L2 and L3 network connectivity over heterogeneous SDN networks. And my partner, Gong Yong-sung, will give more technical detail about Sdn Hub.
Thanks. You're doing a great job. And maybe some of the guys in the Zoom from the Union Pen will, since it is familiar with to him, it is just advanced Shanghai Union Pen solutions. So please allow me to dive deeper into the technical stuff. And we will have three parts of the features. At the bottom is the Sdn Hub orchestrator. We will have two parts, and on the left is the service orchestration layer. The service orchestration layer will to allow the CMP to compose the services, compose the telecom services. And then we will have workflow to run the service composition. To execute it, we will have resource manager and to schedule the resources demands into the bottom OpenStack. And we will have the OpenStack layer. This, in here, we will have Sdn Hub plugin. Sdn Hub plugin will receive the demands from the Sdn Hub orchestrator and then deliver the commands to the bottom layer, Sdn Hub driver. At the top of the Sdn Hub driver, we will have the modeling layers. The modeling layer will deliver that request from the app layers. After that, it will deliver the request into the concrete SDN controller. This is the main task, the main design part, Sdn Hub driver framework. Just as our topic to unifies the heterogeneous Sdn driver, all of this task is finished here. Let's break up into part by part. Let's look at first, see the Sdn Hub orchestrator. On the right side, it is the main path. The main features are central resource management. After this system is set up, we will register the main system resources into the resource manager. And we will also to finish the cross-region resource scheduling. Because all of the resources are registered into the DB, so it has the ability to schedule the demands from the upper layer. And also we will have cross heterogeneous SDN connectivity abilities and network service definition and orchestration abilities. We will use the task template to describe the service requirements. In technical choice, we will use the microservice architecture, such as Spring Cloud Framework. And for workflow engine, we will have codified commander choices. If you guys are familiar with the SDN MV solutions, it is just the kind of an FVO part of the manual systems. So we will to consider the ONAP SDNC. OpenO is the previous version. Okay, let's look at another important part. This is the task finished on OpenStack neutral. And we will use Sdn Hub neutral plugin to replace the current modular layer 2 core plugin, and to support the neutral compatible API layer. And also we will extend the API to extend the API to finish our more API requirement, such as neutral API extension, such as support net or the QoS, more QoS policy, and the Neutron plugin will have the on-demand resource creation. For example, if the CMP requests to create the Neutron network, after the Neutron plugin receives the commands from the SDN orchestrator, it will not immediately deliver the commands down to the Sdn Hub driver until a virtual machine is created on the related network. That is our on-demand resource creation feature. And we will have multiple SDN controllers support. And after the SDN Hub orchestrators schedule and resources will be created or search SDN controller, the request will have a controller ID sent into the Neutron plugin. The Neutron plugin then will send the command down to the specific SDN controller. So that is the multi-SDN controller supports. And another extension is the report network status to orchestrator platform. Orchestrator is our main brain part. And all the status or the monitoring data will be up-reported to it from the Neutron plugin and the related SDN controller parts. So for technical choices, we will extend the Neutron core plugin, and we will have also implemented some advanced Layer 7 services. Oh, that is another main part, SDN Hub driver. SDN Hub driver is a component. If that is the whole system, just like typical SDN applications. From the top, the SDN orchestrator is we can see SDN Hub orchestrator as a SDN application, and the Neutron part is top one layer SDN controller. And then our SDN Hub driver is the middle SDN controller. And the concrete SDN controller that comes from the vendor is the bottom level SDN controller. So we have 3 hierarchical SDN controllers altogether. So just look at the SDN Hub SDN controller. We will have the northbound API, that is a RESTful API. Under the RESTful API is our models, such as Neutron models, the operation and the maintenance models, and some controller and forwarding models. And at the heart of the system is our controller plugins framework. And various vendors will come into our project to provide their implementation of our controller plugin driver framework. So then the plugin can be implemented to call the SDN controller by REST client or RESTful client and netconf client or other vendor-specific methods. So that is the main part, and the technical choices. I think if it is the typical ODL module-driven service abstraction layer framework, and we will choose the YARN tools to provide the runtime and the support of the ODL's YARN modeling language, and also the map structure to support the vendor to write their SDN controller plugins. So that is the main part of the 3 components introduction. And if this is the OpenStack, and in fact, there is a similar project in the community. This is the OpenStack Tricircle. I will talk about something about the OpenStack Tricircle here so that you guys can get more understanding of our project. In the Tricircle, this is the Tricircle's main concept diagram. At the top is the central region, and we will have some bottom regions. That is the true OpenStack to do the job. Okay, in the central region, there is just the neutron plugin. There's no Nova, no Glance, no Cinder, just the neutron here. And we will use the central plugin, neutron central plugin. It is customized for Tricircle. And at each bottom region, it is a complete OpenStack region. And there is Nova, Cinder, Glance, and etc. components. So this neutron will be configured with a Tricircle specific local plugin. Then Tricircle local plugin will sit over real core plugin, such as modular layer 2 plugin. So this central plugin will communicate with the local neutron plugin by RESTful API. And another important part is the Xjob. Xjob is the daemon just running on the central regions. If there is a resources creation request, and that is the resources will cross the bottom regions. When one of the bottom region, on one of the bottom region, the resource is created, it will be synchronized to the central region, and to the central region's Xjob daemon. Xjob daemon will deliver all the information to other bottom regions. In this way, there are three networking across multi-region is formed. And here, the central plugins API is the only entry point. So the bottom region's neutron API should not be exposed to the user or to the other external system. And the main implementation works for community neutron implementation. What is community neutron implementation? Now, if the deployment with Open vSwitch agent, with L3 agent, with DHCP agent, we call it community neutral implementations. So this the kind of Tricircle is working for community neutral implementations, but it's not easy to do the layer 2, layer 3 across the commercial SDN controllers. You know, the commercial SDN controllers is required for our China Telecom's big cloud requirements. So we cannot work on the Tricircle. Now, this is the Sdn Hub. The main characteristics of Sdn Hub is the service orchestration compatibility. We have service orchestration. This is not implemented in Tricircle, and I think it is one of the very important features here. And as I said, as commercial SDN controllers, the SDN controllers, there are about 30 provincial. Province OpenStack is deployed under China Telecom, and all these the network devices are managed by commercial SDN controllers. So this is a big requirement. And we also need to define a standard driver API so that vendor can join us to be part of this project. And we also provide the DCI SDN controller to provide more flexibility when we are doing layer 2, layer 3, or other network resources when it is required to cross multiple clouds. To wrap up the differences here, and the main part is the first one is add service orchestration capability. And then we need to support the commercial SDN controllers and support SDN orchestrator to provide more flexibility when connecting across multi-clouds. Okay, after all this overview or big picture introduction, I'm here to show us some sample activity diagrams to show how we are finishing our jobs. First, let's see the resource registration. Some resources are registered by administrator manually, or some will be registered automatically. Or we will also show network and the subnet creation process. And after that, we will try to initiate one virtual machine. Okay, this is the resource managed by some resource managed by resource manager. This is our Sdn Hub orchestrator. We have said that there are two parts. First part is service orchestration, and the other part is about resource manager and resource scheduler. Some resources managed by resource manager are OpenStack. We will have many OpenStack instances. So we have a model to describe the deployed OpenStacks. We have regions. One OpenStack will have many regions. Okay, you know China, each province is very big too. And every region we will have many available zones. And on the available zone, we have many hosts to do the virtualization. Okay, at the top is our Sdn Hub driver and the Sdn controllers. Each OpenStack will deploy to one Sdn Hub driver, and each hub driver will manage many Sdn controllers. Each Sdn controller will have its own available zones managed. So that is our resource relationship. Based on resource relationship, we will do some resources scheduling. This is after the system is set up, is running. We have, for example, we have installed the 3 parts of the system, and then the administrators need to do something to initiate the systems. So at the top is the CMP. As administrator can go through the CMP to do some resource registration manually. Some system components, such as SDN controller and Sdn Hub driver, and even Neutron Sdn Hub plugin, will register itself and under resources to the resource manager of the Sdn orchestrator. Okay, this is a resource registration and management process. And another one I want to show is that ability to do the network and the subnet creation. Okay, let's start from CMP. On the CMP, The user want to, we just imagine that the user want to create a network. And the CMP will send a request down to the SDN controller orchestrator. The orchestrator will assign network ID and the VXLAN segment ID. After that, the CMP will request to send the demand to the down layer Sdn Hub plugin. You can see that at step 3, Hub Central notifies the regions to create. And at the Sdn Hub plugin, it will create a network and subnet. But at this time, the status is inactive. You can see that network resources are not created by SDN controller. This is just a stop at the OpenStack side. The whole network fabric, we are still not aware of it. Okay. And then, if the user wants to create virtual machines, the CMP first will create a port from the Sdn Hub control platform. The Sdn Hub control platform will do some scheduling, and return the port to create a port model. Return a port with IP, MAC address, network ID, and the regions, availability zone, and even SDN controller ID. All these informations will return to the CMP. The CMP, with this information at hand, the CMP will send the virtual machine creation request to the specific region of the OpenStack. The OpenStack receives the requirement. At step 5, the OpenStack will create virtual machines. And because the Sdn Hub plugin knows the control ID from the scheduling, the Sdn Hub plugin will select the specific controller to create the network resources, such as network, such as the port, and even if we have, if it is another, such as L3 VPN resources, or requested to the SDN controller. Okay, the SDN controller will do its concrete jobs to enable network resources. And at the same time, the normal side will initiate the virtual machine. And at this time, the virtual machine is be connected at the layer 2, layer 3 with the L2, L3 communities. So that is the main part of our topic. Do you need me to do that? Or we'll finish this? It's your plan. Okay.
Okay. So I will talk something about our future plan. Now, we are trying to making Sdn Hub to be open source, open standard, and open industry. Currently, we already use some open source tools in Sdn Hub, including OpenStack and OpenDaylight. As you know, we use OpenDaylight and DSAL framework as the basic framework of Sdn Hub driver. And we will also try to commit Sdn Hub to mainstream open source communities such as OpenStack. If the community is willing to accept this project, we will commit. And we will commit to OnLab community. In fact, Sdn Hub driver is previously an OpenO project, and now OpenO is merged to OnLab. So maybe we will try to commit Sdn Hub driver to our OnLab community too. And we may try to commit this to Open Daylight. And for Open Standard, we already have some standards working on two China's standard organizations, including CCSA and ODCC. And for open industry, this Sdn Hub project already cooperated with many different vendors, including Huawei, CTE, H3C, and 13net, and Nokia, and VMware, and 99 Cloud. I don't know how to spell. Yeah, and we will welcome more vendors to join with us, and that's all our presentation. Thank you.
Do we have time for Q&A? Okay.
Have a question of the code from where they are for your systems code.
Core system.
Yeah.
Which?
CORD is
Okay.
Oh, core system.
Open
CORD.
core.
Open core.
Is mean the open core, CORD.
ONLAP. What was that? Sorry.
Open Network Foundation.
ONF. Okay. Okay, thank you. Sorry.
Okay. Thank you, everyone.
Thank you. Yeah. Mm-hmm.
That makes me confused. Because what I see is that for OpenStack Cloud, normally now the way you will have like 200 to 500 nodes. That is might be something that would make feel quite safe to deploy. And then I'm pretty sure that the single SDN controller can hold all these nodes.
Okay,
So
I think.
don't understand why we need multiple SDN controllers for this network.
Okay, I think this is a good question. Many people ask us the same questions. In fact, I think this problem exists in China Telecom because mainly because of our purchase process. We purchased different vendors SDN solutions step by step, not in one time. And each time when we purchase, we may introduce different vendors, right? The way how we construct our resource pool is very different. We will not construct the entire resource pool in one time, but step by step. And each time we enlarge the resource pool, we will introduce more SDN controllers. So it will come to the reality that at last we will have more SDN controllers in one resource pool. And this resource pool is operated by one OpenStack. Of course, we have other choices like split the resource pool into several small resource pools, but that's not our choices. So it exists in vendors in China Telecom.
So it is a business problem.
Yeah. I think yes,
decision.
much like this. But in the future, maybe after when we enlarge OpenStack to support more and more hosts, and you will encounter these problems in other situations too.
不只是一个。
Yeah.
Why orchestration?
Why orchestration? That's a good question. Yeah, because we have services, and we want to automation these services across the network. We can't do it manually, right? So we need an engine to do these things for us.
But OpenStack already has orchestration.
Depends. In fact, we may have other service that OpenStack cannot cover it. I don't know. I can't give you an example for it. But just think about SDNO in OpenO. it has the ability to automatically configure the networks over the end-to-end network service orchestration. For example, you may want to configure VCPE part and one part and then DC part. OpenStack is just able to manage DC part. It's when things go outside data center, it will have no ability to do that. So that's why we need orchestration. Okay, thank you.